Data dependence graphs. Data dependence graph represents the dependence relation between program statements. Vertices of this graph are statements, and edges are representing the three types of dependencies. So the true dependencies, the anti-dependencies, and the output dependencies. This representation provides a static abstraction of the behavior of the program relative to data usage. Here is an example. I have 8 statements, and for each statement I have a vertex, and between the statement I have the edges representing the data dependencies. So for instance, if I take the relationship between S1 and S2, I have two dependencies, one on A, true dependence, because S2 is using the value produced by A, and I have an anti-dependence in here, because C is read by S1 and it's overwritten by S2. For a basic block, the data dependence graph is a directed acyclic graph. I cannot have cycles into this graph. A basic block is a sequence of statements with one entry point, the first instruction, and one exit point, the last instruction. This is a basic block. In the case of loops, it's a bit different. In that case, the graph may not be acyclic. Let's look at an example. Take this loop. Okay. If I execute this loop, I only have 5 iterations, so I can here unroll all the execution. I have S1 executed for I equal 1, and that will access T1 of 1 and T of 0. And the second iteration, I equal 2, I will actually have a dependencies. The value produced by S1 is at iteration 1 is used at S1 at iteration 2. So if I draw the dependency graph that happens at execution, I will have actually this graph. And this is a true dependence. The problem with that is that usually this is n with values going from somewhere to somewhere. In that case, I cannot use that representation because it would potentially be of size infinite. So what we do a projection on one node per statement of all the data dependencies. So all these nodes are represented by only one, the statement S1. And for every data dependencies that can happen, I actually put between the node, I put one between the corresponding statements from this dependency. So in that case, as you see, we can end up with a cycle. One issue with this is that I'm not distinguishing between loop internal dependencies and the one between iteration. Okay, let's take an example. Again, I have a new for loop, and S1 is computing a value for S2. And if I look at the data dependence graph I have at runtime, I can unroll the loop again in here. I will have S1 that is providing a value here, S1 providing a value for S2, for value I equal 2, I equals 3, same thing. And I have these data dependencies between two iterations. This is iteration 1, and this is iteration 2. So now what I'm going to do is to mark that these data dependencies corresponding to this age, and this age, okay, is not between statements from the same iteration as this one, but it is from statement from different iteration. So you can apply the same idea to nested loops, for instance, in that case, okay, I don't have dependencies, I am only considering this loop, and when I'm doing that, I'm considering that I is a constant for all the duration of the J loop. And so I end up with a data dependence graph with only one edge, which is a loop carries dependencies on J. Here are some questions. If there are no control flow paths from one statement to another, can we have a data dependence between these two statements? Another question, give for this loop the data dependencies. And another question, compute the data dependencies for the following loop. Some references, and see you in class.